Hi, welcome to the EMERTXE internship project work on microwave oven simulation made by Aman Kumar.
So the basic agenda is that the first thing is the introduction, and then moving on to the C programming part, and then the embedded system, and then the demo project. So what have we learned through this internship is that, so what is a microwave oven? A microwave oven is a small oven that cooks or heats food very quickly. Instead of electric or gas heat that a regular oven uses, a microwave oven heats with electromagnetic radiation. So there are basically four modes available in the microwave oven. First is that the micro mode, and then the grill mode, and then the convection mode, and then the start mode. So what are these modes? First, we'll see about the micro mode. This mode is used to cook food in a traditional way. It uses a maximum power of 900 watts. In this, the maximum load is that it takes around 60 minutes for cooking. Then moving on to the grill mode, this mode is used to cook meat and bread. It works same as the micro mode, but the purpose is to cook meat and bread. The user can set the time as per the cooking time of the meat. Then moving on to the convection mode, in this mode, user can set the oven to preheat for a particular temperature, and it takes around 3 minutes to preheat the oven, which is approximately 1 seconds. Then after preheating is done, the user can set the timer as per the requirements, which goes to the start mode. Moving on. Now we're going to deal about the C programming part. So first, we'll see about what is the C language. The C language is a general purpose language, and it is applied and used effectively in various specific domains. The basic number systems used are decimal, binary, octal, and hexadecimal. So we'll talk about a few terms which are involved in the C language. First is the keywords. So what are these keywords? These are words that have a predefined meaning, such as character, char, int, and float. Then the data representation here is bit, byte, and word. What is bit? Bit is known as a basic unit of information in a computer. A group of 8 bits makes a byte. A group of 4 bytes make a word. So what are integer numbers? They can be of positive and negative. Integers are basically a type of data types available in C. These negative integers are represented with 2's complement of positive number. That is 1's complement plus 1. Moving on. So these are the basic 4 data types available in C, as you can see through the flow chart. The first is the integers. The integers are subdivided into short, which is further subdivided into signed, short, and unsigned. And then the integer, which is int, which is subdivided into signed and unsigned. Then moving on to the long, which is also subdivided into signed and unsigned. Then moving on to the float data type, or the real numbers, which is subdivided into float, and then double, and then long double. Then moving on to the third data type, which is the character data type, which is char. And they are of 2 types, which is signed character, signed char, and unsigned char. Then the last thing is that the last data type we are dealing with is that the void data type, which is an empty data type. Moving on. So what are the conditional statements available? So firstly, what is a conditional statement? A condition is something where the first condition is satisfied, only then a set of instructions are executed. There are basically 2 conditions available here. First is the if-else condition, and then the switch condition. This if-else condition is subdivided into if, and then the next if-else, and then if-else if, and then comes the nested if. Then moves on to the switch conditional statements, where based on one condition, a few of the expressions are satisfied, from which one is fixed. Moving on. Then we'll move on to the looping statements. There are basically 3 looping statements available in C, which is the while loop. In while loop, a condition is evaluated before processing the body of the loop. If the condition is true, then only the body of the loop is executed. Do while loop. In a do while loop, the condition is always executed after the body of the loop. It is also called an exit control loop, where the output is based on the condition satisfied first. Whether the output is true or not, the condition is satisfied in a do while loop. Then comes the for loop. In a for loop, the initial value is performed only once. Then the condition tests and compares the counter to a fixed value after each iteration, stopping the for loop when the false is returned. Moving on. So what are the various operators available in C? Before moving on to what is an operator? An operator is a symbol which operates on a variable or a value. There are of different types, like the arithmetic operator, which consists of addition, basic addition, subtraction, multiplication, and modulo division. Then moving on to the logical operations, which consists of the and, or, which are the logical operations, not and XOR operations. Then moving on to the relational operations, where the comparison of 2 operands takes place, which are of which can be of set less than equal to or greater than equal to, and so on. Then moving on to the bitwise operations, where individually, bit by bit, the logical operations are performed. There are some certain special operators available in C, which is the size of operator, which returns the size of each data type. Then the pointer operator, and then the reference operator. Moving on. What is array? Array is also a data type available in C. Array stores data elements of the same data type. Arrays can be used for CPU scheduling. They are used to implement other data structures like stacks, queues, heaps, hash tables, and etc. Collection of data of same data types are basically arrays. So these addresses are sequential, and the basic thing is that the array index always starts from 0. Moving on, pointers. So pointers is a key concept used in C. Pointers store address of variable or a memory location. They are the variables that store the address of another variable. Here we use pointers when you have to return more than one value from a function. This is achieved by a pass-by reference. Moving on. Then comes the functions. So what are functions? A set of statements that are used to perform a specific task. What are the advantages of a function? They are modularity, and they are easy to understand, and they are easy to reuse, where different sections of code can be often reused and called again, and they're easy to debug, and they're simple to understand. Moving on. We'll move on to the main hardware part, where we're going to deal about the basic terms like microcontroller. First, we'll see what is a microcontroller. A microcontroller, what is it? An integrated circuit which is capable of being programmed to perform a specific task. So all the components in a single chip is the microcontroller, which is less flexible and less design complexity. The things to be noted when choosing a microcontroller is the type of application which you're going to use it, and the availability of tools and the performance parameters, and then the special capabilities. Moving on. So we'll deal about what is the difference between a microcontroller and a microprocessor. In a microcontroller, all the components will be placed in a single chip, as it is less flexible and less design complexity. The RAM is of random access memory, and there is a microprocessor inside a microcontroller, and the CPU design is bit easy. And then move on to the microprocessor. All the components are assembled separately, and this is more flexible and more design complexity. Then we'll move on to the embedded system part, where we're going to combine both the software and hardware part together. An embedded system is a microprocessor-based computer hardware system with a software that is designed to perform a dedicated function, either as an independent system or as a part of a large system. And the core is an integrated circuit designed to carry out a computation for a real-time operation. So the example is that the basic examples in real-time applications are washing machine and a microwave oven. Moving on. So what are the various categories of embedded system? They are standalone, which is again classified into slave and independent embedded system. So what is the slave? They don't have any intelligent system in it. Like for example, a semi-automatic washing machine. And then the independent system, where they are intelligent systems. Like for example, the well-famous Tesla car and the Google car. Moving on. The few other categories are real-time systems, where the embedded system takes action within a specific amount of time, like for example, a missile or airbag system. And then the network, where they are connected over a network which is wired, which can be wired or wireless, like for example, a router. And then the mobile, like if an embedded system is movable, then it is movable embedded system, like for example, a robot. Then the hybrid system is a mixture of all the other embedded systems, like for example, a robot or Google car. Moving on. So what are the various memories in the embedded system? The basic memories are read-only memory, which is the ROM, and then the random access memory, which is the RAM. The ROM is divided into PROM, which is the programmable read-only memory. It can be programmed by the user. Once programmed, the data and the instructions in it cannot be changed. Then comes the EPROM, which is the erasable programmable read-only memory. It can be reprogrammed to erase the data from it, expose it to the ultraviolet light. To reprogram it, erase all the previous data. Then comes the masked ROM. Masked ROM, a memory chip that is manufactured with its contents. Then comes the random access memory, which is the main memory. It consists of two types, which is the SRAM, which is the static random access memory. It keeps data in the memory as long as power is supplied to the program, unlike the DRAM, which has to be refreshed periodically. Now we'll talk about what is the DRAM, which is the dynamic random access memory. It is widely used as a computer's main memory. Each DRAM memory cell is made up of a transistor and a capacitor within an integrated circuit, and a data bit is stored in the capacitor. Moving on. Now we'll talk about the embedded system requirements. The first thing is that the reliability, which is the cost effectiveness and low power consumption, and the efficient usage of processing power, then efficient usage of memory. That is, the processor should be consuming less memory and less power. Then moving on to the real-time aspects, which is the hard real-time should meet its deadline like the life critical application, and in firm real-time, it is similar to the hard real-time in terms of the speed and memory. And then moving on to the soft real-time applications, where it can have tolerance in meeting its deadlines. Moving on. Now we'll see about the project. So the basic software requirements are the MPLab IDE and the PixSim Lab simulator and the XC8 compiler. The interfaces are the simplest device used in most on the embedded applications as a feedback work just like the diodes. These are the LED interfaces. And the LED basic program demo, that is the basic LED program, is used for toggling the LEDs connected to the port B. The microcontroller which we use is a PIC 16F877A. We built, the first thing is that we debugged the code and made a project file out of it, which is we converted it into a hex file, and we installed it loaded into the PixSim simulator to simulate the oven. The board we use is PIC Gen IOS board. The microcontroller, as I said, is PIC 16F877A. Moving on. So this is the basic architecture of PixSim Lab. The first is that GPIO pins, which is the input and output processing pins, and the I2C converters, and then the temperature sensors, and then the A to D converters, which is the analog to digital converters, and then we have RTC modules, which is the real-time clock modules, and LED interfaces, buzzers, producing sounds, and then digital keypad for toggling the various actions and commands, and then we have the matrix keypad, and then the clock is in the LCD. So these are connected directly to the PIC microcontroller. Moving on. So this is the sourcing and syncing circuit. So what is the sourcing and syncing? The sync and source are terms used to define the flow of direct current in an electric circuit. A syncing input or output circuit provides a path to the ground for the electric flow. Then we'll move on to the sourcing circuit, which is where the input or the output provides the voltage source for the electric flow. Moving on. We'll talk about the CLCD, which is the character liquid crystal display. In PixSim Lab, there are two types of display, which is the 16x2 display and the 16x4 display. It displays the ASCII character and some special characters. These most commonly used display. There are two types of communication modes, which is the 4-bit mode and the 8-bit mode. Moving on. Then we'll move on, talk about the tactile switching. The tactile switch is a switch whose operation is perceptible by touch. The switch used to select the mode of operation and to enter the temperature and to enter the time in a process. This switch will produce a bouncing effect when a switch is pressed. This is the basic circuit diagram for the tactile switching. Then we'll talk about the triggering methods. There are two types of triggering used, which is edge triggering, where it is a type of triggering that allows the circuit to become active at the positive edge or the negative edge of the clock cycle. Level triggering. Level triggering is a type of triggering that allows the circuit to become active when the clock pulse is on a particular level. Moving on. We'll talk about the MXP, which is the matrix keypad. So this is the keypad in which the number of tactile switches are connected in a row and column concept. This is used when more number of user inputs are required and still want to save more controller input and output lines. So these keypads are most commonly used in telephones, calculators, digital lockers, and so on. Moving on. So we'll talk about the interrupts. What is an interrupt first? Firstly, an interrupt is a communication process set up in a microprocessor or a microcontroller in which an internal or an external device requests the MPU or the MCU to stop the processing. Then the MPU or MCU acknowledges the request and attends to the request. It goes back to the processing where it got interrupted. We'll talk about what is polling. It is the process where the computer or the controlling device waits for an external device to check the readiness or state, often with a low-level hardware. Moving on. So what are the disadvantages of polling is that the loss of events may occur during polling and poor response and then less power management. Moving on. ISR, what is an ISR? What is the interrupt service routine? An ISR is a software routine that hardware invokes in response to an interrupt. ISR attends to the request of an interrupting source by clearing the interrupt flag and should save register contents that may be affected by the code in the ISR. It must be terminated with the instruction RTTIA. When an interrupt occurs, the MPU completes the instruction being executed, then it disables the global interrupt enables. And then it places the address from the program counter on the stack. Then comes the timer part. What is a basic timer? A timer is an important application in any embedded system, which is a default peripheral which maintains the timing of an operation in sync with a system clock or an external clock. It has many applications such as measuring time and generating delays. The timer or a counter is a software designed to count the time intervals between the events. Resolution, which is also called the register with tick, is referred as a change from one number to another number. It may be up count or down count. Quantum, which depends on the system clock setting, is a measure of time which is responsible for the tick. Scaling may be pre-scalar or post-scalar. Then the modes of timers are counter, PWM or pulse generator, etc. Moving on. Now we'll see a short demo of our project. we'll see about the demo now. So this is the basic main file, the main C file which we used, and looking onto the left hand side, you can see all the source files which we've used for the keypads, the timers, and the LCDs. And on top of it is the header files which we've used. What we're going to we're going to convert this into a hex file, and we're going to simply load it into the PixSim simulator. Now we want to go to the PixSim simulator. We already preloaded the hex file, and the clock what we're going to give is that 20 megahertz, which gives us an approximate speed of 0.50. And the LCD display, the segment of LCD display what we're going to use is a 16x4 display. To start it, the microwave oven powers on, and there comes the 4 modes available. First, we'll look at one by one. We'll move on to the micro mode firstly by clicking on the number button 1. It moves on to the power mode, where the power is set as 900 watts. And here we can set the time. We'll set an approximate time of 10 seconds here. The clear is used to clear the input and to redefine a new input. And the hash enter is used to enter the input, confirm the inputs. As you can see, once the input is given, the fan starts, which indicates that the oven is started running. And then there will be 3 options available to resume the oven, which takes us to the stopping the oven, where when key 4 is pressed, the oven starts, and when key 5 is pressed, the oven stops. Since the cooking time is over, the oven stops. Then we'll move on to the second input, which is the grill mode. By clicking 2, we can go to the grill mode. Here again, we're going to give the input time. Here again, we'll set the timer as 7 seconds, probably. Doing OK again. And we'll just click 5 to pause the process. As you can see, once the 5 key is pressed, the operation is paused. And then again, it continues. Now we'll see the third mode, which is the convection mode, where we'll give the input temperature. We'll give as 20 degrees and press hash. The preheating time, which is by default assigned, is at 180 seconds, I'm sorry. So these are the various peripherals available in the PixSim. In this of the key, the matrix keypad, and then the LEDs, the 2x LED or the 4x LED, and then comes the cooler, and there is another buzzer here, and there are different peripherals for various input devices, for interfacing various input devices. So the running of fan defines that the oven is switched on and it's heating. Just to indicate it in a real-time purpose, we're using the the cooler, to indicate the oven's running process. There are different 7-segment displays also available in this PixSim. But we are not going to focus on that one, and we're not going to use that 7-segment displays. As I told you, the microcontroller what we used is that PIC 16F877A. Since it takes too long, we'll just reset it, and we'll reset the button. Now I'll show you how to interrupt start and interrupt while the oven is running. We just move on to the 4th step. Clicking on 4, it automatically sets the time as 30 seconds. Now we'll just try to open the oven. Opening the oven is done by RB3. Once the door is open, you will be prompted as the door is open and please close the door. To indicate that it as a real-time application, we've used the RB3 to toggle that the door is open. So this is the basic functioning of an oven, which includes all the 4 modes. So this is our basic project, what we've learned through the internship. Thank you for giving us this opportunity.